So good morning. Just today we cover the problems on the previous concepts. Now first example is calculate the change in internal energy. Calculate the change in internal energy when gas is expanded by supplying 1500 joule of heat energy and work done in expansion is 850 joule. Is 850 joule. Now, as far as concerned, here first given data are concerned. Given data, if you consider given data, given. So calculate the change in internal energy. Means you have to find out delta U. You have to find out delta U. Question mark. The next, when gas is expanded by supplying 1500 joule, gas expansion by supplying means yes we are given external heat Q supplied to system. So Q supplied to external to the system. So Q is positive. It is positive. So Q is found to be yes 1500 joule of heat energy. Work done in expansion. Work done in expansion. So as work of expansion means it is negative. Work of expansion is negative. So W is found to be minus, it is 850. Minus 850 joules. So remember well, in solving such examples, very what we call as be conscious, be particular with the sign. Be particular with sign one. Signs are very important here. Signs are very important. So as they asked to calculate delta U, so delta U is equal to Q plus W according to first law of thermodynamic. According to first law of thermodynamic. So according to first law of thermodynamic, as far as concerned, delta U is equal to Q plus W. Right substitution is there. Direct substitution is there. Okay, delta U is equal to Q plus W. Q is the Q 1500 joule plus W is the, it is minus 850 joule, isn't it? It is plus minus minus, plus minus minus, and sign comes out to be positive. Sign comes out to be in the sense plus 650 joule. What is the delta U? Change in internal energy. So question may ask for 2 marks. Question may ask for 2 marks. That is the correct formula. That is half mark. Half mark. Substitution half mark, and final answer along with sign. It is 1 mark. It is 1 mark. So remember well, delta U is always written. Delta U is always written along with sign. Along with sign means plus 650 is important. Okay, means change in internal energy is found to be 650 joule. 650 joule. Okay. The next, system absorbs 520 joule of heat. 520 joule of heat is absorbed by system. So here given data are concerned. As far as given data are concerned, given heat is absorbed. So comes out to be Q comes out to be yes positive. It is plus 520 joule and performs work of 210 joule. Performs work means work is performed by the system. Work is performed by the system. So as work is performed, in the sense work is negative. In the sense work is negative. Okay, work is negative. So it is minus 210 joule. Minus 210 joule. Calculate the change in internal energy. Again delta U. Delta U. Again same is the question. Delta U is equal to Q plus W. Delta is equal to Q plus W. So Q is the 520 joule plus, and work is the minus yes 210 joule. So plus minus minus, and overall sign comes out to be positive. So it comes out to be 310 joule. 310 joule. So delta U. This is the delta U. Okay, delta U. So change in internal energy, always write in this way. That is change in internal energy of system is 310 joule, and square bracket. Make square bracket like this. And here also that is the change in internal energy, again 650 joule. 650 joule. Okay. Then what's the next example? That is a calculate the work done in each of the following reactions. State whether work is done on or by the system. First reaction is oxidation of 1 mole of SO2, that is twice SO2 gas plus O2 gas, use twice SO2 at 25 degrees Celsius, and decomposition of 2 moles of ammonium nitrate. So by the reaction, ammonium nitrate solid, NH4NO3 solid, use twice N2O gas plus twice H2O gas at 100 degrees Celsius. At 100 degrees Celsius. So first we consider the first case, that is the oxidation of 1 mole of sulfur dioxide. So if you carefully observe, actually they in return they ask to calculate, that is the what we call as the work done, and we have to give the explanation regarding the work is done on or by the system. But in this case, they ask for 1 mole, but in reaction, actually 2 moles of sulfur dioxide is given. So if you use this reaction as such, use this reaction as such for the calculation of number of moles delta N, question is wrong. So always be careful that if they ask to calculate for 1 mole, you have to convert this reaction for 1 mole. For the reaction, 1 mole. So for 1 mole, same reaction can be written as SO2 gas plus 1 by 2 O2 gas converts into SO3 gas. Okay. Means we have to calculate the work done. So formula for work done in chemical reaction, W is equal to minus delta nRT. Then for this reaction, if they calculate delta N, this is the number of moles of product minus actually sum of number of moles of product minus sum of number of moles of reactant is there. Okay, and remember, in the calculation of number of moles, solids components is present one, they are not considered one. So product number of moles, here 1 is there. Okay, 1 minus here 1 and here 0.5. Okay, 0.5. So 1 plus 0.5, it is 1.5. So minus 1.5. So it comes out to be, yes, 0.5. Okay. Plus minus 0.5. This is the 0.5 is the number of moles of the what we call as change in number of moles. Change in number of moles for the reaction is 0.5. Then after the calculation of change, but one more point, that is the sign as far as concerned. Here minus sign, 0.5, isn't it? Okay. Then R is the gas constant. Okay, gas constant, it is 8.314 joule per Kelvin. 8.314 joule per Kelvin per mole, and temperature is given at this reaction is at 25 degrees Celsius. So if you calculate, W is equal to minus delta nRT. So minus, again in bracket, it is minus 0.5 into, yes, into R, it is a gas constant, 8.314 into temperature. Temperature will convert into Kelvin. So 273 plus 50. And if you solve all these things, one, it will give the answer, that is plus 1347. Plus 1347 point comes out to be 7 joule. And remember here work is positive. So work is positive in the sense work of compression is there. Work of compression, which is again what we could derive from the number of moles. As number of moles is negative, as number of moles, change in number of moles are negative, as delta N is negative, therefore it is work of what compression takes place. The number of moles decreases from reactant to product, so compression takes place one. And again it is clear from the sign of W, it is positive. Work of compression is there. If you consider the second case, it is for ammonium nitrate. Actually decomposition of 2 moles of ammonium nitrate, but here reaction given for 1 mole. If you use this reaction as such, question is wrong. Answer is wrong one. So convert this reaction for 2 moles. So if you convert this reaction for 2 moles, just write the 2 values or multiply the all components of the reaction by 2. So twice NH4 NO3 solid converts into twice N2O gas plus 4H2O gas. So again same, you have to use the W is equal to minus delta nRT. Here first calculate delta N. Delta N is equal to sum of number of moles of product minus sum of number of moles of reactant. So number of moles of product, here N2O 2 moles, water 4 moles, so 4 plus 2 6 moles, 6 minus here number of moles 2. Don't use this 2. Why? Because ammonium nitrate is in the solid state. And I already told you, if your solid components are not considered there, means their number of moles are not changes one, or not considered one, solid, isn't it? So it is 6 minus 0, it comes out to be plus 6 mole. It is the change in number of moles. And again R is the same. Temperature is given at 100 degrees Celsius. So minus 6 moles into, that is a 8.314 into 273 plus 100, that is 373. And if you solve this, now as here indicates, as number of moles are increases from reactant to product, as number of moles are increases in the sense it is, yes, expansion, this expansion. And as expansion takes place, so work of expansion is negative, so this negative sign as such it is given here, no conversion, positive होणार नाही तर negative as such राहणार. And the final answer comes out to be 18.606, 18.606, it is kilojoule, it is kilojoule, it is work. This work is the work of expansion, so just here write calculate the burden आपण काढलेला आहे, पण पुढे काय म्हटलेलं आहे इथं, yes, state whether work is done on or by the system. So in previous case, in first case sulfur dioxide, work comes out to be plus 1347.7 kilojoule. Okay, so this is the sulfur dioxide case मध्ये number 1A साठी, this one is the for B case. A case, yes, work is positive in the sense it is work of compression, and as work of compression in the sense gas is compressed in the system cylinder, that's why work is done on the system, work is done on the system, it is work is done on the system here. In the B case, negative, so work of expansion, in the sense gas inside the cylinder pushes the piston in the upward direction, that's why expansion takes place. So here work is done by the system, work is done by the system, work is done by the system on the surrounding, work is done on the system by the surrounding. Okay, so you may write this, you may solve the some extra questions of the same concept. Okay, next lecture we see the next part. Good day.